Okay, here's the last example, example 7 from the 14.3 notes. All right, so we want to use sigma notation to rewrite each sum. So we want to work backwards in this case, where we want to start going this way. So we're going to start with the sigma notation. And then at the bottom you're going to start, and usually it's easiest just to start with k equals 1, and that's going to represent the first term. And so then you count how many terms there are to know when to stop. So in this case there's 1, 2, 3, 4, 5 terms. So at the top my stopping point will be 5. And now I want to figure out what equation will represent this sum in this series. So what equation is going to represent it? Well, on the top, notice those all had 1s on the top, so it's definitely going to be a 1 on the bottom. Then if I'm starting with k equals 1 down here, it actually is 2, so how would I get there? I have to do k plus 1, and that would work each time. Because my second term, it's 2 plus 1, my third term is 3 plus 1, 4 plus 1, 5 plus 1. So you can always plug it back in just to check your work, but this would be the sigma notation that would represent that first series. The next example, same way you're going to start, k equals 1. In this case, there's 4 terms, so I'll stop at 4. And the equation that'll represent it, well, notice they all have x's on the top, but if I look at exponents, it's x to the first, second, third, fourth. So that's just x to the k, because it's starting with 1. And then my denominators are just k. 1, 2, 3, 4. And I'm done. There are more than one correct answer depending on where you decide to start. If you started with k equals 0 or k equals 2 or something like that, you could have a slightly different equation for that one. For C, sigma notation. Again, start with k equals 1. When I go up here, notice this, where am I getting the 1? It's really going to be the coefficient up at the top. 1x, 2x, 3x, 4x. So that's going all the way up to 12x. So my stopping point will be 12. And then my equation, on the top it's just kx, because it's, notice, 1x, 2x, 3x, 4x. On the bottom, though, it's not k factorial, it's k plus 1 factorial every time. Because you're starting with 1, so if I plugged in a 1, that'd be 1 plus 1, which is 2 factorial. For the second one, 2 plus 1 factorial, 3 plus 1 factorial, 4 plus 1 factorial, etc. And that would be a correct answer for C. For D, we again can start with k equals 1. And then when I'm looking at this, I got to see, well, where's my equation going? The coefficients are again going to give me that k, 1, 2, 3, 4, 5. So I'm going to have a k in front for the coefficient. And so I'm going all the way up until 9. I'll stop at 9. And then the exponents are what we want to talk about here. And the exponent is only the exponent of the x term, right? So it's x to the second, x to the third, x to the fourth, x to the fifth. So that exponent is k plus 1. And then the last thing I have to worry about is that notice that the signs switch. It's positive, negative, positive, negative, positive, negative. There's lots of different ways to do the negative part. One of the easiest ways is just to make that x term be a negative. So if I think about that, right, and that negative x, and if I do 1 plus 1 for the first one, 1 plus 1 is squared, so the negative will disappear, so that first term will be positive. Then if I plug in a 2 here, 2 plus 1, it'll be to the third power, negative x to the third power, that would give me the negative there. And then switch back and forth, positive, negative, positive, negative. Okay, so that's one really easy way to take care of that negative. And that's it. I don't know how to get out of this. Oh, there we go.